section 1, chapter 3, lesson 3. So factoring trinomials in the form AF of x squared plus BF of x plus C. All that really means is in 2-to-1 ratio, and we're going to talk about that right now. We're still going to use basically today inspection decomposition process, like I told you before we started the notes. The process is the same. You still do inspection the same. You still do decomp the same. You're just dealing with a little bit higher order. The biggest thing we have to look for when we're factoring is we need a 2-to-1 ratio of our terms. What I mean by that is when we were doing the normal stuff, it was a square and an x1, right? It was 2-to-1. So if I change this to 4 and a 2, it still can use the same process. It's still in a 2-to-1 ratio. Okay? So when you're doing factoring with higher exponents, they just need to be in a 2-to-1 ratio for us to feel comfortable. See this right here? That's still 2-to-1. I feel like them rewriting it like this kind of confuses people, so I don't really go over that as much. But my point is that just pretend that this is just a normal x squared per second. What are factors of 6 that add up to 5? 2 and 3. And what I do actually for me, I just steal the middle. I know it has to be this. You're done. So it's the same factoring process. We just wrote an x squared because of the higher order. Only thing that changes really. Okay? Here, 2-to-1 ratio, we can still factor it. Factor the 6 to add up to 5, the same process. 3 times 2, 6. And then see how the x squared times x squared will give me the x4. So that's really what we're doing today. So coming down here, let's look at these examples. So again, a4 minus 5a squared minus 14. Yikes, an a4. Well, it's not a big deal. It's 2-to-1. So we follow the same process. Negative 14 that gets me negative 5 is negative 7 and 2. Right? So we're done. It's going to be a squared minus 7, a squared plus 2. That's it. Now, in these ones that you do have an a squared in there, so I would tell you to look out for difference of squares. If you get a difference of squares, you're going to go down one more time. We'll see that here shortly, like next. Okay? What would b factor 2? What would b factor 2? X squared minus what? Minus 1 minus plus 5, right? X squared minus 1, x squared plus 5. 5 times negative 1 is negative 5. 5 plus negative 1 is 4. This is what I was talking about. X squared minus 1 is a difference of squares, so we need to unwrap that a step further. That is your completely factored form. This is what, yeah, they're the same thing, but you will want to do a completely. If it says factor completely, this is not complete. So yeah. Throw a 6 at you here, but still, it's 6 to 3. That's still 2-to-1, so we still feel good about that. Factors of 14 that add up to negative 9, negative 2, and negative 7. So we are at x cubed minus 7, x cubed minus 2. Remember, order doesn't matter, those numbers. Okay? All that stuff's fine. Any questions? Like I said, see, same process, right? Same process, you got to organize your exponents. All right, so they're going to talk about the decomposition part here. I'm just going to go right to it. Decomposition, we're still just looking for the 2-to-1 ratio, and we still do our same process of decomp. I actually think decomp organizes it easier for you, because when you GCF, when you pull out an x, you're just going to pull out an x squared, because they have an x squared in common now. So the organization of decomp kind of forces you to actually organize your exponents anyways. Okay, so let's just try one here. 4 times negative 6, so we got negative 24. So we're doing our decomp just like in the warm-up. Factors of negative 24 is negative 8 and 3, so we're here. And then we're going to be 4x4 minus 8x squared plus 3x squared minus 6. We're going to group now, and this is what I was talking about. Right, the first group has a 4x squared in common, so we're pulling a 4x squared out. So that gives me x squared minus 2. Second group just has a 3 in common. That gives me a x squared minus 2, and then we're good. They match. We're done. That's it. Okay, so again, really the work hasn't changed. The work hasn't changed. That's why I keep trying to stressing people. I know when you look at these, you're like, whoa, that looks scary, but it's not bad. It's still the same work. So this one, a double variable. I think decomp really helps with double variables. Okay, so 2 times 99, we still have to do, which is not a very familiar number, 198. So 198 that breaks into 31 is common here, but I'll help. 9. Now that's how we're breaking the middle up. So it's going to be b squared minus 22ab minus 9a. And now we get GCF. So what's the first piece have in common? 2ab. So we take a 2ab out. That gives me ab minus 11. What's the second one have in common? Negative 9. ab minus 11. Perfect. 2ab minus 9. ab minus 11. So right there. All right, we've got one more before we go into a little bit different mode. Okay. All right, let's try this one. 8x to the 4th, 10x squared. We're still in 2-1 relationship, so we feel fine. There's no GCF or anything, so I'm going to decomp. 8 times negative 3 for negative 24. Factors negative 24 that gets you 10 would be 12 and negative 2. So here we go. 8x4 plus 12x squared minus 2x squared minus 3. So we're going to group. 4x squared comes out of the first piece. That gives me 2x squared plus 3. Second piece, the negative 1 comes out. We get the match again. 4x squared. Oh, there's an alert. Why is that an alert? Yep, difference of squares. 4x squared minus 1 is 2x plus 1. 2x minus 1. And then we have our 2x squared plus 3. That's our completely factored form. Okay. All right. We just have one more page here. Okay, just 4 more examples. Yeah, you would get a half point off if it's not being completely factored. Yeah, so you got to look out for those difference of squares. If it's asked to evaluate or stuff rigor, you can get away with it because it still gives you the same answer. But factoring, if it's just simply saying factor completely, that's kind of the key there. Okay. All right. Okay. So, and the reason is because when you get to higher, you want to have it factor complete to see zeros. So if you have factor completely, you can see all the answers. If you don't, you can't see all the answers. Okay, so right here, given that sine x squared is written in the form of sine squared x, so we're just saying that this is the same thing. Okay, and cosine squared x is cosine squared x, like the same that they've written there. But the key thing here is I have a squared x. So we don't really care about this. If the signs really bother you, I told last class, you can just write this as this, it's fine. And we can just treat it normal. It's not a big deal. Okay, if you don't like the signs, just put them back in at the end. Okay, it's kind of a substitution form. We're going to kind of do that in a second. Okay, so we go 6 times 2 is 12. We're still doing decomp. It's still a decomp problem. It's still a 2-to-1 ratio. 12, factor 12 to get you negative 7. Negative 4, negative 3. We're good? So we got 6a squared minus 4a minus 3a minus 3. So we're here. We have a 2a in common. 3a minus 2. 3a minus 2. Oh, plus 2. I was going to say, why is that a 3? Thank you. So this is minus 2. Okay, and so then we'd pull a negative out. Plus 2, sorry. So we pull the negative out, that gives me 3a minus 2. And so if I pull a negative out, that means negative 1. So we have 2a minus 1 times 3a minus 2. Put your sign back in for your a's. Remember, don't leave it in a's. So write 2 times sine x minus 1, 3 sine x minus 2, like that. That would be your finished product there. Right, it was just kind of using a substitution and write it cleaner. You can sign the whole time too, if it doesn't bother you. Some people like to just write, they don't like bringing in an A. You can just write sign. The A will help us more for the next section. I think the next section's messier. But yeah, like this one, 4a squared plus 11a minus 3 is kind of what we're looking at. So negative 12 would be 12 and minus 1. A squared plus 12a minus a minus 3. Yeah, 4a, a plus 3, negative 1, a plus 3. 4a minus 1 put together, the a plus 3, and then we'll write it with our cosines. Oops. So there's your finished product there. All right, and I'll give you a forewarning here, because a lot of people do this often, make the problem way longer than it needs to be for the next section. Any questions on those two? We're okay? Okay, so when you get down to this part, a lot of people, when they first look at this, they totally lose sight of the factoring piece. People will FOIL this out, they'll distribute this, and they'll combine it all and then try to factor. And that's just a big mess, okay? When you see these little binomials, one's written squared, one's written not, still factoring 2-to-1 ratio, okay? Often, like I said, often I've seen numerous times that students will FOIL all these things out and have a big mess and get lost and leave it blank, okay? You just need. Okay, so 7a squared minus 4a minus 3. My a is equivalent to x minus 3, just remind yourself. So all we've done is we just subbed out the x minus 3 for a second, because it's in a 2-to-1 ratio, and now we're still doing decomp. So it's just all the same work we've been doing this whole lesson, really. Negative 21. So we have 7a, negative 7 and 3 is what we're looking at. 7a squared minus 7a plus 3a minus 3. Pull a 7a out. A minus 1. Pull a 3 out. A minus 1. So we're here. And we are going to put the a back in as the x minus 3, excuse me. And so we want to make sure we simplify that. Okay. So we do want to simplify this, so we're not done. We do want to go ahead and fully put those together because we have like terms in here. So the first one, for example, is going to be 7 times x, 7 times negative 3. So you have a 7x minus 21, and then it's plus 3. 7x minus 21 plus 3, 7x minus 18. X minus 3 minus 1, x minus 3 minus 1, that's just, it's not multiply, it's minus. So that's x minus 3 minus 1 is x minus 4. That's your finished product. All right, we got one more. So again, I'm just going to stay with the a. You can use any letter you want. Okay. A plus 4. So 9 times a squared plus a minus 9 times negative 90. Factor negative 90 to get you 1 is 10 and negative 9, though. So we'd be at 9a squared. We can just put the minus 9a with it, plus 10a minus 10. Pull the 9a out. Minus 1. Pull the 10 out. A minus 1. Nine a plus 10. A minus 1. Now we're ready to plug the a back in. So times a plus 4 plus 10. And we have a plus 4 minus 1. I know my a's and 9's are close. Apologize. So this would be 9a plus 3 distribute. We have a plus 10. So this last piece would be 9a plus 46 for that final simplified version. This means 4 minus 1 for a plus 3. And that one's done. Okay. So I told you to start this, level. They raise the level of factoring with a process. If your process is solid, you're still going to be in good shape. Okay, so stay with the process.